This is the EdExcel GCSE 9-1 Maths Paper 1, which is a non-calculator paper, and it's from the sample papers. Question number 1, we have to work out 6.34 multiplied by 5.2. Well, there are many ways in which we can do this question. One way is to use the grid method. So for the grid method, we can split up the 6.34 and the 5.2 into its digits and then multiply through in the grid. You can see here for the 6.34 we have split that up as 6, 0.3 and 0.04, and for the 5.2 we have split that up as 5 and 0.2. So now if we multiply through, 5 times by 6, that's 30. 5 times by 0.3, that's 1.5. 5 times by 0.04, that's 0.2. 0.2 times by 6, that's 1.2. 0.2 times by 0.3, that's 0.06. 0.2 times 0.04, that's 0.008. So now we need to add together the 30, the 1.5, the 0.2, the 1.2, the 0.06, and the 0.08. So if we add together all these numbers, it turns out we get 32.968, and therefore 6.34 multiplied by 5.2 is 32.968. Question number 2, we have to expand and simplify m plus 7 lots of m plus 3. Well, m multiplied by m, that's m squared. M multiplied by 3, that's 3m. 7 times by m, that's 7m. And 7 multiplied by 3, that's 21. And therefore, m plus 7 multiplied by m plus 3, that will be m squared. Now, if we collect together like terms, 3m plus 7m, that's 10m, and then we have 21. Question number 3. AE, DBG and CF are parallel. DA equals DB equals DC. The angle EAB is equal to the angle BCF, which is equal to 38. We have to work out the size of the angle marked X. You must show your working. So first of all, you'll notice here we have a Z angle. So the angle ABD is equal to 38 degrees. And similarly, the angle CBD is also equal to 38 degrees. The reason for that is we have alternate angles. So let's just write that down. So ABD, which is equal to CBD, is equal to 38 degrees because we have alternate angles. Now, you'd also find that the triangle DBC and the triangle ABD are both isosceles, and that's because we have two lengths of equal size. Of course, here AD is equal to BD, so we have an isosceles triangle here, and because BD is equal to CD, we have a isosceles triangle here. So let's just write that down. So the triangles DBC and ABD are isosceles because we have two sides of equal length. And because of that, this angle over here will be 38, and this angle here will also be 38. The reason for that is we have base angles in an isosceles triangle which are equal. So BCD is equal to BAD, which is equal to 38, because base angles in an isosceles are equal. Now we can find the other angle from these triangles, recognizing that angles in a triangle add up to 180. So this angle will be 180 minus the 38 minus the 38, and this angle will be 180 minus the 38 minus the 38. So this angle and this angle will be equal. So let's actually work out those angles. So the angle ADB, which is equal to the angle CDB, is equal to 180 minus 38 minus another 38, which is equal to 104. So if we go back to our diagram, this angle is 104, this angle is also 104. So let's write down the reason for that. Of course, you'd find angles in a triangle add up to 180. And with this, we can find out the angle x, recognizing that angles around a point sum to 360. So we can work out the angle x. X is equal to 360, take away the 104, take away the other 104, which is equal to 152. So the angles around a point sum to 360, hence x is equal to 152 degrees. Question number 4. Gary drove from London to Sheffield. It took him 3 hours at an average speed of 80 kilometers per hour. Lynn drove from London to Sheffield. She took 5 hours. Assuming that Lynn drove along the same roads as Gary and did not take a break, we have to work out Lynn's average speed from London to Sheffield. Well, of course, here we have a speed, we have a time. What connects those is distance. So what we can do is use speed equals distance over time to find out the distance from London to Sheffield. So here you can see distance is equal to the speed multiplied by the time. So let's use that to find out the distance from London to Sheffield. So from London to Sheffield, the distance is equal to the speed, 80 kilometers per hour, multiplied by the time, which is 3 hours. So therefore the distance is equal to 240 kilometers. Now with this, we can find out Lynn's average speed by using the fact that the average speed is given by the distance over the time. So therefore Lynn's average speed is equal to the total distance, that's 240 kilometers, over the time she takes, which is 5 hours. Of course, her average speed will be 48 kilometers per hour. So therefore, her average speed is 48 kilometers per hour. And now for part B of the question. If Lynn did not drive along the same road as Gary, explain how this could affect your answer to part A. So her distance would be different and therefore her average speed would be different. And that's assuming she does not drive along the same roads as Gary. Question 5. In a company, the ratio of the number of men to the number of women is 3 to 2. 40% of the men are under the age of 25. 10% of the women are under the age of 25. And we have to find out what percentage of all the people in the company are under the age of 25. Well, if we use this ratio, you can see here 3/5 of the people in the company are men. And of course, 3/5 is equivalent to 60%. So 60% of people in this company are men, and 2/5 of people in this company are women. And of course, 2/5 would correspond to 40%. So 40% of people in this company are women. Now, it says here 40% of the men are under the age of 25. So we have to find out 40% of 3/5 to find out the number of men under the age of 25. Now, of course, 40%, that corresponds to 4/10. So 4/10 of the 3/5 is what we need to work out. So 4/10, which corresponds to the 40% of men, of the 3/5, this will equal 12 over 50, which is equal to 6 over 25. And we need to convert this into a percentage. So if we multiply the top and bottom by 4, then you'd find 24% of men are under the age of 25. So we have 24% of men with age being less than 25. And we can use a similar idea to find out the percentage of women under the age of 25. So here we have to work out 10% of the 2/5. So here, 10%, that corresponds to 1/10. So we have 1/10 of the 2/5. This will of course equal 2 over 50, which is equal to 1 over 25. And if I multiply both the top and bottom by 4, you'd find 4 over 100, which corresponds to 4%. The 4%, of course, is the percentage of women with an age less than 25. So therefore, the percentage of all people under the age of 25, this will be the 24 plus the 4, which is 28. So we have 28% of people in this company who are under the age of 25. Question number 6. The plan, front elevation and side elevation of a solid prism are drawn on a centimetre grid, and in the space below, draw a sketch of the solid prism, write the dimensions of the prism on your sketch. So, let's start off with the front elevation. From this point going horizontal, we have 5 centimeters. So let's just show that. Here we have 5 centimeters. We'll add the dimensions on after. Then from this point going up, we have 4 centimeters. So let's show that. Here we have 4 centimeters. Doesn't have to be super accurate. From this point we've got 3 centimeters going across. From this point we've got 2 centimeters down, then 2 centimeters to the right, then 2 centimeters down. So we have something like this. So this is the front elevation. So let's add on the dimensions. Here we have 5 centimeters. Here we have 4 centimeters. Here we have 3 centimeters. Here we have 2 centimeters, and here we also have 2 centimeters, and this is also 2 centimeters. So let's just show that here. So we've got 2 centimeters here and 2 centimeters here. Now let's think about the plan. Well, this point, rather this line over here, would correspond to this, and this would correspond to this. And if we take a look at the side elevation, of course this would correspond to this, and this would correspond to this. But the plan tells us that the length here is 3. So if we show that, here we would have 3 centimeters. So let's just show that like so. Okay, so let's just show the 3D shape as we see here. So finishing it off, here is the .3D shape, and of course here we have 3 centimeters. So this is the 3D sketch of the solid. Question number 7. There are 1,200 students at a school. Kate is helping to organise a party. She is going to order pizza. Kate takes a sample of 60 of the students at the school. She asks each student to tell her one type of pizza they want. The table shows information about her results. So of the 60, 20 want ham, 15 want salami, 8 want vegetarian, and 17 want margherita. And we have to work out how much ham pizza Kate should order. We have to write down any assumption you make and explain how this could affect your answer. So, of the 60 students in her sample, 20 of those want a ham pizza. So therefore, 1/3 of students want a ham pizza. Now, we will assume that this sample reflects the whole school, so therefore 1/3 of the 1,200 This will tell us the amount of pizza with ham flavouring she should order. So 1/3 of 1200, this is equal to 400. So she should order 400 ham pizza. So when we come to write about our assumption, so we have assumed that the sample reflects the whole school. However, not all students may go to the party, and therefore she may have to order less pizza. Question number 8. Here is a parallelogram, and that's what we see here. We have to work out the value of x and the value of y. Well, the first thing to notice about this parallelogram is the opposite angles are equal. So because opposite angles are equal, the 5x minus 20 is equal to the 2x plus 43. And now if we solve for x, first of all, of course, we need to subtract 2x from both sides. And we would also need to add 20 to both sides. So if we do that, you'd find 3x is equal to 63. And now if we divide both sides by 3, you will find x to equal 21. Now, what we should also know about a parallelogram is that the adjacent sides add up to 180. So because the adjacent angles add up to 180, the 5x minus 20 plus the 4y minus 5x will equal 180. Now, we know that x is equal to 21, so we have 5 times by 21 minus 20 plus 4y minus 5 times by 21 equals 180. And happily for us, you'd find this cancels with this. So we have minus 20 plus 4y equals 180. And if we add 20 to both sides, you'd find 4y to equal 200. And now if we divide both sides by 4, 200 divided by 4 is 50. So therefore, y is equal to 50. So we have x is 21, y is 50. Question number 9. We have to work out the value of 9 times 10 to the minus 4 times 3 times 10 to the 7. Give your answer in standard form. Well, standard form is when a number x is being multiplied by 10 to the power of n, and of course x is in between 1 and 10. Now, we need to multiply the 9 by the 3, and if we do that we get 27. And if we multiply the 10 to the minus 4 times 10 to the 7, we'd have to add the powers. Let's think about why that's the case. Well, of course here when we have the same base number raised to a power, we add the powers. So here we have a to the power of m plus n. So here we've got 27 times by 10 to the minus 4 plus 7, which is the same as 27 times by 10 to the 3. Now of course we need to express this in standard form using this idea. We don't want a 27, we want a 2.7 instead, and because to go from 27 to 2.7 we divide by 10, here we'd have to multiply the 10 to the 3 by 10 to get 10 to the 4. So in standard form we have 2.7 times 10 to the 4. So we have 2.7 times by 10 to the 4. Question number 10. For part A, we have to write down the value of 64 to the power of 1/2. Well, this is equivalent to taking the positive square root of 64, which is equal to 8. For part B, we have to find the value of 8 over 125 to the power of minus 2/3. Well, of course here, whenever we have a minus power, we'd have to find the reciprocal of what's inside the bracket. So we have 125 over 8 raised to the power of 2/3. Of course, the minus has now disappeared from the power. Now what this is equivalent to is finding the cube root of 125 over the cube root of 8, and then raising this result to the power of 2. So the cube root of 125, that's 5, and the cube root of 8, that's 2. So we have 5 over 2 to the power of 2, which is equal to 25 over 4. So 8 over 125 to the power of minus 2/3 is 25 over 4. Question number 11. One uranium atom has a mass of 3.95 times 10 to the minus 22 grams. For part A, we have to work out an estimate for the number of uranium atoms in 1 kilogram of uranium. First of all, you need to recognize that 1 kilogram is the same as 1000 grams. And the reason I want to express the kilogram in terms of grams is because one uranium atom has been expressed in terms of grams. Now, of course, if we write this in standard form, 1000 is the same as 1 times by 10 to the power of 3. So 1 kilogram is the same as 1 times 10 to the 3 grams. Now, we're finding out an estimate for the number of uranium atoms in 1 kilogram of uranium. So to find out how many of these fit into 1 kilogram, we'd have to divide 1 kilogram by 3.95 times 10 to the minus 2. So if we work out this, we have 1 kilogram, which we've just said is the same as 1 times by 10 to the 3. We divide this by 3.95 times by 10 to the minus 22. So this is approximately equal to, if we work this out, well, here on the top we've got 1 times by 10 to the 3, and the 3.95, we can round this up to 4. So here we've got 4 times by 10 to the minus 22. And now we need to work this out. Now, of course, you'd recognize here we have the same base number with 10, and we're dividing. So a to the power of m divided by a to the power of n is the same as a to the power of m minus n. We subtract the powers. So here, 1 divided by 4, well, that's just 0.25. And then we have 10 to the power of 3 take away minus 22. So here we have 0.25 times by 10 to the 25, and if we were to write this in standard form, of course, for standard form, that's when a number x is multiplied by 10 to the power of n, where x is in between 1 and 10. So here we have 2.5, so we're multiplying this by 10, and if we multiply this by 10, we have to divide this by 10. So we have 2.5 times by 10 to the 24. And now for part B, is our answer to part A an underestimate or an overestimate? Well, here it's an underestimate because we've rounded the denominator up. So we have an underestimate because the denominator has... Question number 12. Pressure is equal to force over area, and we have to find the pressure exerted by a force of 900 newtons onto an area of 60 centimeters squared, and we have to give our answer in newtons per square meter. So clearly here we would have to convert the 60 centimeters squared into meters squared, because this would correspond with the area. So the way to think about this is, well, if I want to go from centimeters to meters, here I would have to divide by 100, and that's because there's 100 centimeters in 1 meter, and to go from meters to centimeters we'd have to multiply by 100. Now, to go from centimeters squared to meters squared, I'd have to divide by 100 squared, and to go from meters squared to centimeters squared, we'd have to times by 100 squared. So we can convert the 60 centimeters squared into meters squared by multiplying, well, rather by dividing by 100 squared. So 60 divided by 10,000, this is equal to 0.006. So we have 0.006 meters squared. So therefore, pressure is equal to the force. We know the force to be 900 over the area, which is 0.006. So if we write this out neatly, we have P equals 900 divided by 0.006. So if we work this out, of course, to get rid of this decimal, we can multiply both the top and bottom by 100. So on the bottom we've got 6, and on the top we've got 900 multiplied by 100, which is 90,000. So if we divide 90,000 by 6, it turns out here we'd get 15. Rather, here we have to have another 0. So here we'd end up with 150,000 newtons per meter squared. So we have here 150,000 newtons per meter squared. Question number 13. Rectangle ABCD is mathematically similar to DAEF. We know that AB is equal to 10 centimeters, that's shown here, and AD, that's equal to 4 centimeters. We have to work out the area of rectangle DAEF. Well, the way I like to do these sorts of questions is to draw the shapes out separately. So let's do that. Here you can see we have the rectangle DAEF, and let's draw out the rectangle ABCD. So here we've got the rectangle ABCD. Now AB, that's 10 centimeters, so let's add this in here. And AD, that's 4 centimeters. And obviously this will also be 4 centimeters. This length and this length are of course the same length. So what we can do is find out the length scale factor to find out how we go from the small shape to the large shape, or vice versa, from the large shape to the small shape. And we do that by dividing the corresponding lengths. So the length scale factor, that will equal 10 over the corresponding length here, which is 4. So here we get 5 over 2 for the length scale factor. And therefore, to find out what df is, df will equal, well, first of all, let's think about what this represents. To go from the small shape to the large shape, we'd have to multiply by 5 over 2, and to go from the large shape to the small shape, we'd have to divide by 5 over 2. So df, that's equal to 4 divided by 5 over 2. Well, this is the same as multiplying 4 by 2 over 5. Now 4, that's the same as 4 over 1. So here we get 8 over 5. So this length here is 8 over 5 centimeters. And therefore, to find out the area is equal to 8 over 5 multiplied by 4. Now 4 of course is the same as 4 over 1. This is equal to 32 over 5. So we have 32 over 5 centimeters squared. So we have 32 over 5 centimeters squared, and we can have its decimal equivalent 6.4. Question number 14. Ben played 15 games of basketball. Here are the points he scored in each game, so that's what we see here. For part A, we have to draw a box plot for this information. Well, the first thing we can do is find the minimum value, and clearly, because the data is already in order, the minimum value is 17. So 17 is the minimum value. The maximum value is 28. So the maximum value is 28. We now need to find the median. So to find the median, because we have 15 values, 15 plus 1 over 2, this will equal 16 over 2, which is 8. So we want the 8th value to find the median. So we've got 1, 2, 3, 4, 5, 6, 7, 8. 22 is the median, and we'll call this median Q2. Let's find the lower quartile. The lower quartile is equal to 1/4 of the total number of games. So we have 15 plus 1 over 4. So this will be 16 over 4, which is 4. So we want the 4th value for the lower quartile. So we've got 1, 2, 3, 4. 18 over here is the lower quartile, Q1. And for the upper quartile, we have 3/4 of 15 plus 1. So 1/4 of the 16, that's 4, times that by 3, we get 12. So we want the 12th value to find the upper quartile. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the 12th value is 26. So therefore the upper quartile is 26. Let's now draw a box plot. So in terms of a scale, I think an appropriate scale would be from 16 to 28. So let's just grab our ruler and let's draw a line here. And let's label on the 16. Then here we've got 18. Then we've got here 20, then 22, 24, 26 and 28. And if we draw our box plot, well, we've got a lower quartile at 18 and our upper quartile is at 26. So we can show this as we see here, and we draw the vertical lines. You can see we have our lower quartile, our upper quartile, and we have here the median, which is 22. And for the lower quartile, rather for the minimum value, we've got 17. And for the maximum value, we have 28. And if we join these up like so, here is our completed box plot. Now, for part B of the question, Sam plays in the same 15 games of basketball. The median number of points Sam scored is 23. The interquartile range of these points is 12. The range of these points is 20. Who is more consistent at scoring points, Sam or Ben? You must give a reason for your answer. Well, before we do anything else, we've been given the interquartile range for Sam, that's 12. We can find the interquartile range for Ben. So, the interquartile range, IQR, for Ben, this is equal to 26, take away the 18, which is 8. And for Sam, we were told the interquartile range is 12. So when we talk about whose scores are more consistent, Ben has more consistent scores, and that's because the interquartile range is smaller than Sam's, and we see that over here, 8 is smaller than 12. Question number 15. In a shop, all normal prices are reduced by 20% to give the sale price. The sale price of a TV set is then reduced by 30%. Mary says 30 plus 20 equals 50, so this means that the normal price of the TV set has been reduced by 50%. Is Mary right? You must give a reason for your answer. Well, what we will do over here is assume that 100% represents the original normal price. So the normal price is 100%, and after the first reduction, if we reduce by 20%, the first reduction is 20% off 100%, which is equal to 80%. And with the second reduction, we reduced the sale price of a TV by 30%. So for the second reduction, we have 30% off the 80%. Well, here we divide the 80 by 10, so that's 8, and timesing it by 3 to give the 30%. This will equal 24%. Okay? So therefore, the total reduction, so let's write this down, the total reduction is equal to 20 plus the 24, so this is the first one and this is the second one, which is equal to 44%, and therefore she's wrong. Question 16, we have to factorize fully 20x squared minus 5. Well, in terms of numbers, the highest common factor of 20x squared and 5 is 4. So we've got 5 lots of, well, here we're going to have 4x squared because 5 times by 4x squared gives 20x squared, and then we've got the minus 1 because 5 times by minus 1 is minus 5. So then we need to recognize that 4x squared minus 1 can be written as a difference of 2 squares. So here we've got 5 lots of 2x plus 1 lots of 2x minus 1. So we have 5 lots of 2x minus 1 lots of 2x minus 1. Question number 17, we have to make A the subject of A plus 3 equals 2A plus 7 over R. Well, the idea is over here we need to get the A by itself. And the first thing we can do is multiply both sides by R, and if we do that, you'd find we have A lots of, rather we have here R lots of A plus 3 equals 2A plus 7, because the R's here cancel out. We now expand the R into this bracket, so we have AR plus 3R equals 2A plus 7. We now gather all the terms involving an A on one side, everything that's not an A on the other side. And we can do that by subtracting 2A from both sides, and also subtracting 3R from both sides. So we have AR minus 2A equals 7 minus 3R. We can now factorize the left hand side. A is a common factor, so we have A lots of R minus 2 equals 7 minus 3R, and if we divide both sides by R minus 2, we can therefore conclude that A is equal to 7 minus 3R over R minus 2. So we have A equals 7 minus 3R over R minus 2. Question number 18. Solid A and solid B are mathematically similar. The ratio of the surface area of solid A to the surface area of solid B is 4 to 9. The volume of solid B is 405 centimeters cubed. We have to show that the volume of solid A is 120 centimeters cubed. Now I think it might be a good idea if we summarize this information. So you can see here the ratio of the surface areas of A to B is 4 to 9, and the ratio of the volumes of A to B is x to 405, and our job is to find out what x is. Before we do anything else, it might be a good idea to work out the area scale factor. Now, to go from the small shape A to the big shape A, we need to think, what do we multiply 4 by to get 9? Well, obviously that will be 9 over 4. So the area scale factor is 9 over 4. And therefore the length scale factor can be used to find out the volume scale factor. The length scale factor will be 9/4 square rooted, which is 3 over 2. And therefore the volume scale factor, this will equal the length scale factor cubed. So we have 3 over 2 cubed, which is 27 over 8. And we can use this information to find out what x is. So the way to do this, well, there's a couple of ways. We can, first of all, divide 405 by 27 over 8 to find out what x is. So therefore, x will equal 405 divided by 27 over 8. So here we've got 405 multiplied by 8 over 27, and if we work this out, indeed we get 120. So therefore, x is 120 centimeters cubed. Question number 19, we have to solve x squared being greater than 3x plus 4. Well, first thing we do is rearrange so we have something being greater than 0. So gather everything on one side, so we have x squared minus 3x minus 4 being greater than 0. We can now find out our critical values by replacing the inequality sign with an equal sign, and if we do that, we have x squared minus 3x minus 4 equals 0. So, if we factorize, we have x minus 4 lots of x plus 1 equals 0, from which we can see for our critical values, we have x equals 4 and minus 1. So if we draw a graph to illustrate what's going on, let's draw ourselves a quick set of axes, like so. We've got the y-axis, we've got the x-axis. Our quadratic is in between 4 and minus 1. So look, something like this. Here we've got the minus 1 and here we've got the 4. We're looking for where the graph is greater than 0, is greater than 0 here and here. So therefore, our solutions, we have x being greater than 4 and we've also got x being less than minus 1. Question number 20. We have shape A over here and we have to enlarge shape A by scale factor minus 2, center 0, 0. Well, if we think about, for example, this point here, and if we make it go through the origin like so, let's just show the lines which help us find out the shape. And then we've got this point goes through the origin as we see here. If we stretch it out like so, we've got that other point. Similarly with this one, we scroll down a bit, goes through the origin like so, and then we've got this one which goes through the origin like so. Okay, so for this point over here, this one is from the origin 1 across 1 up. So if we go the other way, we go, bearing in mind we've got a scale factor of minus 2, we go the opposite way by 2 and down 2, so that's this point over here. Okay, perhaps if we show that in the red, we've got this point and the corresponding point will be over here. If we consider this point over here, that's 1 across 2 up, so here we go 2 across and 4 down to this point here. Then we've got this point, so here we go 3 across 1 up, so here we're going to go 6 this way and 2 down, so that's this corresponding point. And then for this one, we've got 2 across 2 up, so here we're going to go 4 this way, 4 down to this point here. So now we need to join all these up with a straight line. So if we do that, we've got something looking like this. So this over here is the shape B. And now for part B, describe fully the single transformation that will map shape B onto shape A. Well, here the center will be the same. Obviously it's going to be an enlargement, and we're going to have a negative enlargement because we're going to the opposite quadrant, but the scale factor here will be a negative a half because the shape is getting 2 times smaller. So we have an enlargement scale factor minus 1/2 with centre at the. For question 21, here is a speed time graph for a car journey, and the journey took 100 seconds. The car travelled 1.75 kilometers in the 100 seconds, and we have to work out the value of v. Well, first of all, what we can do is, well, before anything, you'd realize that the speed here is in meters per second. However, the distance here is in kilometers. So it makes sense for us to first of all make sure we're consistent with our units. We need to convert the kilometers to meters. So we will convert from the kilometers to meters, and to do this, of course, we need to multiply by 1000, and of course, if we want to go the other way, we can always divide by 1000. So therefore, the 1.75 kilometers is the same as 1750 meters, because 1.75 times 1000 is 1750. Now what we can do is find out the area of what's under the graph. That's because the distance under graph, the distance travelled corresponds to the area under the graph. So let's find out the area over here. We have, of course, a trapezium. So the area of this trapezium, we're going to have 1/2 times by the sum of the two parallel sides. Well, here we're going from 20 to 60, so this length over here will be 40. And then we add on this length over here of 100. And then we multiply by the height, which you can see is v. And this is equal to the total distance travelled, 1750. And we need to find out what v is. So here we've got 140 times by 1/2, that's 70. So we've got 70 times by v equals 1750. And if we divide through by 70, v is equal to 1750 over 70. Well, this is the same as 175 over 7, which is equal to 25. So the value of v is 25. And now for part B, we have to describe the acceleration of the car for each part of this journey. Well, first of all, let's just label each of the 3 parts of the journey. We've got this first part, we'll show with a 1, the second part with a 2, and this third part with a 3. Well, we know that v is 25, so here we have 25 meters per second as the maximum speed. So for the first part of the journey, we accelerate constantly for 20 seconds until we reach a speed of 25 meters per second. So we increase with constant acceleration for 20 seconds, and then after 20 seconds, because the speed is constant, this means the acceleration is 0. So for the second part of the journey, we have no acceleration for 40 seconds because we have constant speed. And if we take a look at the third part of the journey, because we have a negative gradient here, we have constant deceleration for the final 40 seconds. So we decrease with constant acceleration for the 40 seconds. Question 22. Bhavna recorded the lengths of time in hours that some adults watched TV last week. The table shows information about her results. So we've got here the length of time shown in this column and the frequency shown in this column. And Bhavna made some mistakes when she drew a histogram for this information, and we have to write down 2 mistakes Bhavna made. Well, first of all, if we take a look at the frequency density axis, you'd find over here she's plotted the frequencies instead of the frequency densities. So that's the first mistake. So that's what's mentioned here. We've plotted frequency instead of frequency density. And if we also pay attention, the interval from 20 to 40 has been plotted incorrectly. They've shown from 20 to 50. So 20 to 40 is shown as 20 to 50, and that's what we see here. Question number 23, we have to show that 1 over 1 plus 1 over root 2 can be written as 2 minus root 2. Well, before we do anything else, let's just copy this out. We have over here 1 over 1 plus 1 over root 2. Now, we need to multiply each term by root 2. So this is equal to, if we write this down, well here we've got 1 times by root 2, which is root 2. Then we've got 1 times by root 2, which is root 2. And then we've got 1 over root 2 times by root 2, that's just plus 1. Now, to simplify this, we need to multiply both the numerator and the denominator by the conjugate of the denominator. In other words, we multiply top and bottom by root 2 minus 1. So we will multiply both top and bottom by root 2 minus 1. So if we do that, root 2 times by root 2, that's 2. Root 2 times by minus 1, that's minus root 2. Root 2 times by root 2, that's 2. 1 times by minus 1, that's minus 1. So now if we tidy this up even further, 2 minus 1 is 1. So indeed we end up with 2 minus root 2. Question 24. John has an empty box. He puts some red counters and some blue counters into the box. The ratio of the number of red counters to the number of blue counters is 1 to 4. Linda takes at random 2 counters from the box. And the probability that she takes 2 red counters is 6 over 155. How many red counters did John put into the box? Well, the number of red counters is unknown, so we can let x be the number of red counters. So with that, if we let x equal the number of red counters, the ratio of the number of red to blue will therefore be x to 4x. Now, with this, we can conclude that we can draw a tree diagram given this information. So here is our tree diagram, and let's just fill in the different entries. Well, first of all, out of 5x, pens, one of those x's will be red, and 4 of those x's out of the 5 will be blue. Now if we take a pen, that means the number of pens will now be 5x minus 1. So let's just write it down for each of these. We have 5x minus 1. Okay. So here we've got 5x minus 1. Now, if we select a red pen, then the number of red pens we'll now have will be x minus 1. And if we select a blue pen, given that we select a red pen, well, that's not going to change. That's still going to be 4x. And if we select a red pen, given we've selected a blue pen, well, that's not going to change. That will still be x. And if we select a blue pen, given that we've already selected a blue pen, it would have 4x minus 1. Now, the probability that she takes 2 red is equal to 6 over 155. So the probability of selecting 2 reds is equal to 6 over 155. So if we select 2 reds, that will be the same as selecting x over 5x and then selecting the 5x minus 1. Then here we've got the x minus 1. And all of this will equal, of course, 6 over 155. So now if we expand and simplify all this, well, on the top over here, we'll have 25x squared minus 5x being on the bottom, and on the top we'll have x squared minus 1. And here we'd have 6 over 155. So now we need to tidy all of this up. So if we multiply through by 155 and then 25x squared minus 5x, you'd see here we've got 155 lots of x squared minus 1 equals 6 lots of 25x squared minus 5x. So if we expand and simplify, we've got 155x squared minus 155 equals, well, here we'd have 150 x squared minus 30x. So if we tidy all this up, you'd find we have 5x squared minus 125x equals 0. So if we factorize, we have 5x lots of x minus 25 equals 0. So we either have 5x equals 0 or we have x minus 25 equals 0. So from this, because x cannot equal 0, from here, so x can't equal 0 from here, otherwise we'd be dividing by 0. We can therefore conclude from here that x is equal to 25. So therefore the number of red pens we have will be 25. Question 25. A has coordinates minus 2, 1, B has coordinates 6, 5, and C has coordinates 4, k. And these are the vertices of a right-angled triangle ABC, and the angle ABC is the right angle. Now we have to find an equation of the line that passes through A and C, give your answer in the form AY plus BX equals C, where A, B and C are integers. Well, I think the best way to approach this question is to draw a diagram. So if we draw a diagram like this, here you can see we've got the x-axis and here we've got the y-axis. And if we draw on the triangle ABC, it will look something like this. So we've got a right angle triangle like so over here, and here is our right angle, and if we add the coordinates on, we've got the coordinates of A minus 2, 1, so this is the coordinates of A. Okay, so let's just write this here. we've got the coordinates of B, 6, 5, and the coordinates of C, 4, K. So our job is to find out the equation of the line that passes through A and C. So we need to find out this equation here. Now, let's think about how we can do this. Well, we know that the gradient of AB is perpendicular to the gradient of BC. And with that, what we can do is, well, let's just find out the gradient of AB before we do anything else. So, the gradient, well, let's just move this diagram to the right a bit. So the gradient of AB, this is equal to, well, we've got the change in y, so that will be 5 take away 1 over the change in x, 6 take away minus 2. So you'd find over here the gradient of AB is, well, on the top we've got 4, on the bottom we've got 8, so the gradient is 1/2. Okay? And therefore, knowing that AB and BC are perpendicular to each other, we can conclude that the gradient of BC is equal to the negative reciprocal of 1/2. So here we've got minus 1 over 1/2, which is equal to minus 2. So what we can do is find out the equation of BC over here. And the reason I want to do that is, if I know the equation of this line, I can use that to find the coordinates of C, i.e. find out the value of K, and from that find out the gradient of AC, and then the equation of the line AC. So, if we find out the equation of the line BC, so line BC, using y equals mx plus c, you can, well, we don't have to use y equals mx plus c, we can also use y minus y1. Let's just write it down. We can use the fact that y minus y1 equals m lots of x minus x1 to find out the equation of the line. Okay, so we've got y minus any coordinate here, so here we can have y minus 5 equals gradient minus 2 lots of x minus 6. So therefore, if we tidy this up, you'd find y to equal minus 2x. Well, here we're going to have positive 12 plus the 5, which is 17. So we've got y equals minus 2x plus 17. You could have also used y equals mx plus c if you wanted to as well. And if we substitute in the coordinates of k, rather if we substitute in the coordinates of c, which is 4k, we've got the y coordinate k. This is equal to minus 2 lots of the x coordinate 4 plus 17. So here we've got minus 8 plus 17, which is 9. So therefore, we have the coordinates of C being 4, 9. Now with this we can find out the gradient of AC. So therefore the gradient of AC, this will equal, well, we're going to have 9 minus 1. Okay, so here we're going to have 9 minus 1 over 4 minus minus 2. And you'd find the gradient here to equal 4/3. So therefore, for the line AC, again using y minus y1 equals m lots of x minus x1, we've got y minus 9 equals 4 over 3 lots of x minus 4. And now we need to tidy all this up. So if we multiply through by 3, we've got 3y minus 27 equals 4x minus 16, and therefore in the required form, we'd have 3y minus 4x equals 11. So our equation of the line is 3y minus 4x equals 11.